All right, one more circuit analysis example. So I've got a combo circuit. It's got some in series with each other. It's got some parallel to each other. So we'll try this one first. Again, this question, and they're not all like this. Just so happens that the ones I've chosen here to show you all are starting with giving you all the R's and the overall V. I can't find I's anyway. I can't find V's anyway. I think what I have to do is I have to start by finding the total R. So when I look at this, how am I going to take these four resistors and crush them into one? Can I add these two together? No, because there's a split in between. Can I add these two together? No, because there's a split to here. I can't add these with each other yet, but when I look at just these two right here, they are in series with each other and there's nothing else happening in between. So what I'm going to do is I'm going to redraw this as that, whoops, and that. Yeah. This will be 20 ohms. This guy is 20 ohms. And this guy right here, let's calculate it. They are parallel to each other, so I'm going to use this little formula. So 1 over R is equal to, this would be 5 over 150 plus 3 over 150, and I get 8 over 150. But that's 1 over R, and I'm not interested in that. So what I'm going to do is I'm going to inverse this side, and I'm going to inverse this side. I get 150 over 8, which just so happens to be 18.75 ohms. This guy right here is 18.75 ohms. Now I just have 3 in series with each other, 20, 20, and 18.75. I'm going to turn them into one super resistor just by straight up adding them together, and I'm going to get 58.75 ohms. Wonderful. So now I have the total R. I have the total V. I can find the total I. I0, this is the current that leaves the battery, is V0 over R tot, which is 10 over 58.75, which works out to be 0.17 amps. Wonderful. So now I'm going to cross a couple of things off. That guy goes, and that guy goes. So now let's take a look at a couple of currents here. The current that leaves the battery is 0.17 amps. And that current, 0.17 amps, 0.17 amps, 0.17 amps, 0.17, there's been no turns. So in this example, the current that leaves the battery is also the current that goes through resistor number 1. And on the way back, it's also the current that goes through resistor number 4. So I guess what I'm going to write next is I0 has got to be equal to I1, which has got to be equal to I4 because of the car rule. Yes. Which is equal to 0.17 amps. Now I know I1 and I know I4. Well, if I know I1 and I4, that means I also know R1 and R4, so I can find V1 and V4. So let's do that now. V1 is I1 R1 and V4 is I4 R4. 0.17 times 20 is what it was, and this is also 0.17 times 20, which gives me 3.4 volts. 3.4 volts. Wonderful. Let's go back up to our diagram. So mom gave me $10, and I just calculated I'm going to spend 3.4 here. I'm going to spend some here, and I'm going to spend another 3.4 here because I just calculated right down there. I just calculated V1 and V4. Both of them are 3.4. So I know I'm going to spend 3.4 here. I know I'm going to spend 3.4 here. Mom gave me 10. How much am I going to spend in that store? Let's do that quick little calculation. It's an easy one. I know that that mom gave me $10, and I'm going to spend it in store 1, store 2, and store 4. That was 10. This was 3.4. Not sure what that one is, and this one was 3.4. It looks like V2 is going to be equal to 3.2 volts. Now a similar calculation, mom gives me $10. Let's just go back up and take a look at that. Mom gives me $10. I could go spend 3.4 there, some in this one, and then another 3.4 before I go back and see her. So I can do the same type of calculation because the numbers are the same. I'm going to get the exact same, whoops, that's a 3. I'm going to get the exact same number. Yes. So I have V2 and V3 and V1 and V4, so I'm going to pause for a second. I'm going to go up here. I'm going to start cancel. I got all the V's now. Bang, 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 and bang. I also figured out I1 and I4 using the car rule here. Looks like I'm just left with I2 and I3 out of all the things I had to find. So I'll go down here and I can use Ohm's law to find I2 would be V2 over R2. V2 we already calculated right here is 3.2. R2 off the original diagram itself was 30. I get 0.11 amps. And I can do the exact same thing with I3. It's going to be V3 over R3. V3 is also 3.2. R3 was 50, and I get 0.06 amps. Now, just as a little check, just like we did in the second example question, 0.17 amps leaves the battery, goes down here, and it splits. Some goes this way, some goes that way. How much will go this way? More current will go this way because the resistance is smaller. This one's harder to get through. Not as much current is going to go that way. So it's going to split not equally. If they were both 30 or they were both 50, it would split half and half. The current would split half and half, but it's not. These are not the same. So, but I know that 0.17 goes down here and some goes this way and some goes this way. So if I calculate this and this, when I add them together, I should get 0.17. Did I? Oh, 0.111. 0.06. When I add those together, I do indeed get and that again is a quick little check that makes me happy that I didn't seem to mess up all the numbers on the way through. And I'm going to go up here, one final thing. I'm going to get out my red and I'm going to go pow pow. Done. I found everything. I am done this question.